Okay, number one, gay lussacs. Now we have pressure and temperature are our two things we're working with. We're not doing volume. Volume is constant, so it cancels each other out. This is also a direct proportion relationship. So if one goes up a certain proportion, the other is going to go up the same. If one goes down, the other is going to go down the same proportion. Okay, so let's see what we got. We got a P1 that's 55 kPa. We have a T1, which is 24 degrees Celsius. We don't know what our P2 is, and our T2 is 15 degrees Celsius. Okay, first thing we notice is that our temperatures are in Celsius. And when you're doing the gas laws, you should always do everything in Kelvin. It's the only way the proportions work right. So let's look at T1. So T1, right, we have to convert 24 degrees Celsius to Kelvin, right? So we know that Kelvin equals degrees Celsius plus 273 Kelvin is going to equal 24 plus 273, and Kelvin is going to equal 297 Kelvin. That's our T1. Now our T2, we plug everything in. Again, Kelvin equals degrees Celsius here. This is 15 degrees Celsius. We don't have to put the Celsius there. Plus 273. We add them together. So Kelvin here is going to equal 288 Kelvin. So let's plug this in. So P1 is 55 kPa over T1, which we did right here, is 297 K. And that's going to equal our P2, which we don't know. And we're going to divide that by our T2, which is right here, 288 K, right? We cross multiply, you get 297 K times P2 equals 55 kPa times 288 K, right? And you solve for P2. Now you notice that temperature went down slightly. So if temperature goes down slightly, pressure should go down slightly. And when I did the math, the pressure came out to 53.33 repeating kPa. Okay, and again, very slightly pressure went down because temperature went down slightly.